We're going to solve some more complicated algebra questions today, and we're talking about some of these are problems off of the AP Calculus AB problem set. And it's going to require rules such as power rules and factoring rules that we know. A couple of rules to keep in mind as we go through would be a to the negative m equals 1 over a to the m power, and a to the m times a to the n is equal to a to the m plus n. We'll use those in one way or another. Now, when we go through this, we want to simplify it before we do anything major. And the first thing that we're going to see is that the first expression is going to be all multiplication. You're multiplying 1, 2, 3, 4, 5, 6 terms. And I can simplify that by taking the 1/2 times the negative 2 and just getting a negative x in that particular location. So you're left with negative x. I'm just going to rewrite it so I don't miss that x there. And so at this point, I can also do one more thing, because you have a negative x times x squared. So now all of a sudden I can get rid of that negative x by writing it as negative x to the third power, because x squared times x is x to the third. So I can actually eliminate this term by sucking it into that term. All right. Now I have an easier expression. I have 1, 2, 2 terms here, and I have 1, 2, 3 terms here. And at this point, I want to factor. The equation is basically solved for x. You have terms plus terms equal 0. And instead of having a sum, you want a product. If you have a product, you can use the zero product property that says 1 is equal to 0 and the other one is equal to 0. So the next question is, how do I get this term plus this term into a product? The way you do that is to factor. You're going to factor out the greatest common factor of both terms. So when you're looking at these two terms, this one and this one, you're now trying to think, what can I pull out of both of them? If you look at the numbers first, usually you do like numbers and then variables and then expressions. So if I look at the numbers first, I can't do anything with the numbers. I then go to the expressions. Expression would be x and x to the third. So the first thing that I want to do is actually pull out an x from both of them. So what's going to leave? I'm going to leave an x squared here, and I'm going to leave 1 here, because 1 times x is x. But I want to also pull out as much as I can out of both of these terms before I distribute. So the other thing that I want to look at now is this 1 minus x squared to a power. 1 minus x squared to a power. It's the same base. I can pull out a term of that same base to make this easier to work with. Now, when I do that, I have to be careful, because my exponents are not the same, they're different. I'm just doing this to make it easier to work with. And this is the trick in the problem at this step. How can I pull this out? 1 minus x squared to some exponent. When I pull it out, I want to make it easier. Now, I either want to pull out 1 minus x squared to the negative 1/2 power, or I want to do it to the positive 1/2 power. If I do it to one of these, it's going to make it a lot easier when I go through this. Okay, so I'm just going to put a little box here, because I want to put something in that box to pull it out, and then it'll make things easier. I pulled these things out. What remains is going to be what I multiply that by in order to get what's above it. All right, so what that means is this on the left times something has got to equal what I did up here, plus this on the left times this thing has to equal this thing on the right. It's a distributive property, here to here. All right, so the first thing I'm looking at is this times what is going to give me this? Well, I know I have a negative x cubed here, x, so this has to be a negative x squared, because x times negative x squared equals negative x cubed. All right, that's done. The next thing I have is this term. Now, what I want to do is either pull out a negative 1/2 or a positive 1/2 to make this easier to work with. Let's just try the negative 1/2 and see if that works for me, because if I did do that, what remains in this first term is just going to be 1. So I know that this times this gives me what's up and above it. Plus, now I'm going to the second term. I'm looking at my number. It says 2x. There's a 2 here, so the first thing I'm going to write down is a 2. So now I have 2x, and now I have to think a little bit, because this negative 1/2 is not the same as that 1/2. So if I were to do this, I have to put in 1 minus x squared to some exponent such that when I add these exponents, I get 1/2. So I have to think 1/2 plus what gives me 1/2? Well, if you want to, you could just say, well, I can't do that in my head. 1/2 plus what gives me 1/2? And then you can see pretty easily that answer is just going to be 1. Which helps a lot, because now you're not dealing with that exponent anymore. So what goes in here is 1, and you chose that negative 1/2 correctly, and that's what you want to use. You don't want to use positive 1/2, or else that exponent is going to be harder to work with. So I'm happy with that negative 1/2. I distribute this through. I get both terms what's above it, and it's equal to 0. Now I have it in a way that it's multiplying things equaling 0, which means any of those factors can equal 0. Any of these three factors can equal 0, and that's solving for x. So, for example, x equals 0. I look in the original. Can x equal 0 as you go through? Sure, why not? That's one of my answers. I then go to the second one, which is this one. 1 minus x squared to the negative 1/2 is equal to 0. That looks messy. I could say 1 over 1 minus x squared to the positive 1/2 is equal to 0. That looks messy. But you know what? This is what AP Calculus does, is it makes you think. It just doesn't say do things on autopilot and then get an answer. It makes you think, what can x be now such that this fraction will give you 0? Well, I'm thinking out loud here. If I put in 1 here, I'm going to get 1 divided by 0. 0 on the bottom, that's really undefined. That doesn't work. I really can't get a 0, because 1 divided by anything is not going to give you 0. There's nothing I can put in there. Therefore, guess what? That is not one of my answers. It does not exist. Then you're down to the third one. Now, when I do this last one, negative x squared plus, I'm going to distribute that 2 through, because I see that I'm going to have an x squared term. And then when I do this, I get negative 3x squared plus 2 equals 0. Negative 3x squared equals negative 2. And to make a long story short here, you're talking about x equaling the square root of plus or minus 2 divided by 3. And again, when you get an answer, you're always going to want to check it in the original. Can you do it? Because if I had a square root and this is negative, then that would not give me a correct answer. So I put that back in the original and put square root of 2/3 and square it. That becomes 2/3. 1 minus 2/3, that's a positive number. That's going to work, and it's going to work here as well. So no reason why that can't work. Here's my second answer. Those are the two answers, or three answers, that I can get when I go ahead and solve this problem. Again, in summary, because there's a lot going on here, what did I do? I first looked at the equation. Can I knock anything out to make this problem easier? That answer was yes. Get rid of the -2 and the 1/2. And combine your x squared with your x. 2, after you get it as simple as possible, factor. What can I pull out of both of these expressions? You chip away at it. The trick was this base to the -1/2 power. Always use that -1/2 power and it'll work out nicely. And then third, I set each of those equal to 0 and check my answer. I want to get started on the next problem, which is the second problem. The directions to the second problem, which are just on the back side, are to simplify or put in simplest factored form. To put in simplest factored form, that means basically combine everything and then factor it. But the directions remain the same up front. Do what you can do to make this easier before you get started. Think about things that you can do that will actually simplify this whole problem before you dive into it. Now, when you're looking at this problem, you should be thinking, well, there's a times 0 in there, and anything times 0 is 0. So you definitely want to say that is equal to 0. The second thing you want to do is say, I have a minus, and this is going to be a -2 up here, so minus -2 is the same thing as 2. So I can also say that's going to be a plus. Now I can rewrite this into a much easier fraction than what I see. This fraction is going to be now, the 0 plus anything is the thing, so it's going to be 2x to the 4th over x plus 1 squared. That's a lot easier than what's up above it. Okay? Small steps, but really make the problem easier. Students will say, oh, these problems, I can't handle them, they're just so big. But you know what? When you narrow this down to this, all of a sudden it's definitely doable. And then the second one. The second one, again, thinking up front, is what can I do to the second part of this to make that easier to read? Now, this is not about solving for x again. It's combining and then factoring. You have two fractions. You want to combine them and then factor at the end. So to do that, I want to simplify this expression right here. Well, what is that expression? It's really x plus 1 over x plus 1, right? 1 is with the is the same thing as x plus 1 over x plus 1. I got common denominators. Now I can actually make this into one fraction that will be easier to work with. So it's going to be x plus 1 on the bottom. And on the top, I'm going to think about this. It's x plus 1 minus 2. So that just becomes x minus 1. Again, that makes it a lot easier to work with than what's up above it. I'm simplifying it to a point where it's easy to work with. This is the same thing as over 1. You now have two fractions. workable fractions with different denominators. Your job on this one is to get common denominators and then add or subtract the numerators and then simplify and possibly factor. That will take you through this one, and then on the last one, you have one more problem on the back side. That's all you're doing for Wednesday, is complete this problem, finish the third problem, and if you want to, you can check your answers with me before you go.